Hello calculus students, this is Mr. Bean, and today we're talking about trig integrals. This is really not that hard, but there will be a bit of memorization that you have to be able to do. So if you like memorizing things, this is right up your alley. If you don't, I'm sorry, we got to do it anyway. Okay, so first, let's remember what are the 6 trig derivatives. Pause this video right now, write them down because the answers are about to appear and I want to test you to see if you can do these on your own. Okay, so there you have our derivatives, which you're used to. Now when we're going to talk about the integrals, it's just going backwards from these. To do these trig integrals, usually what I find to be the easiest way of doing it is to think cosine x. If I wanted the integral of cosine x, well, what would give me, if I was taking the derivative of a trig function, what would I have to start with to take its derivative to get cosine? Like if this was the answer. So if you understand what I'm talking about here, if I took the derivative of sine, you'd get cosine. So I know that the integral of cosine must be sine. So let's do, how about this one?
What would I have to take the derivative of in order to get the answer of sine? It would be negative cosine. If you had negative cosine and took its derivative, you'd get sine. So you can see here how these are related. Now this one's a little easier, secant squared, because it's the answer to the derivative of tangent. So there's our integral. And then over here we've got negative cosecant x cotangent x. Its integral would be cosecant x. So probably what I also could have done on this one was just left off this negative. Maybe that would have been better to have done that. Left off the negative, and then you know that this would have been negative cosecant x. So just be careful about this one. You could write it either way, as long as you remember that there's got to be a negative there somewhere. And then this one here, secant x tangent x. Its integral is secant x because the derivative of secant x is, of course, secant x tangent x. And then the last one, so cosecant x, its derivative, or excuse me, its integral would be negative cotangent x because this derivative gets me back over here to cosecant squared x.
Okay, so this is just pure memorization. Do not get confused between integrals and derivatives. So what I'm going to do in the practice today is you're going to actually be doing both the integrals and derivatives within the same lesson so that you can kind of keep track of which way you're going, because it's a very easy thing to make those mistakes, to forget which one this is, an integral or a derivative. Okay, one more rule here. This is going to be preparing for U substitution, something Mr. Brust will teach when we get to Unit 10. You're not actually going to do full-on U substitution. And just so you know, this U substitution, if you wanted to kind of make a note of it, this is kind of like reverse chain rule. That's what that is. You remember chain rule? Well, if you had to do something with chain rule, if you look at this thing, there would be a chain rule thing going on here because you've got a number in front of x where a is a number. So if you had that, you'd have to use a chain rule for the derivative. For integrals, we call it U substitution. But basically, this one is so simple that all you have to do is write this formula down, this little thing, and that is that its integral of the integral of cosine would be sine ax, and then you just divide by a. Okay, so that's how you take the integral. I do have a plus c here, and I didn't put any of those on these. Technically, yes, I'm being lazy, and I should have said plus c on all of them. You don't have to write all those out because for you it's just memorizing that these are what's in red here. You don't have to memorize the plus c part because yes, you should obviously know that by now. So make sure you have this written down, and let's go on. First example, find the indefinite integral. Okay, so we go -5. So the -5, this part here, this could just kind of come outside the integral, properties of integrals, when we're taking when we're integrating. So what is the integral of sine x? That would be a cosine x with a negative in front, right? And then you on the plus c, and then you also have the -5 that we moved to the outside of it. So this is multiplication here. So then you have the answer would be 5 cosine x plus c. Next one, 2 over secant x. So sometimes we have this situation where you've got this 1 over, like are we going to use a logarithm? You know, when you start getting into more U substitution, you might try that because it's a number. So again, I could pull this 2 to the front. Let's do that. 2 integral. Now, this would be 1 over secant x. That's the same thing as cosine x dx. So sometimes it's helpful if you can rewrite the trig expression so that it's an integral that is much easier for you. That is where all of those Pythagorean identities and crazy trig identities come in handy from pre-calculus and from trigonometry, because it helps you with calculus if you can rewrite it. So this was a reciprocal identity, and then we get 2 times, now what is the integral of cosine? That would be sine x plus c, and there's our answer. Number 3, now we're going to use definite integrals to do these. So we're going to plug in some values. First one, -2. Well, that's just going to come on the outside here. That's fine. And then the integral of cosine is going to be sine. We just did that one. Sine x. And then we're going to evaluate it from pi over 4 to pi. So let's plug in that pi first. -2 sine pi. And now I'm going to say minus. I tend to just do the whole thing again. So I'm going to say -2 sine of pi over 4. So then this becomes -2 times sine of pi is 0 plus 2. And then sine of pi over 4 would be the square root of 2 over 2. All right, so this is just 0. The 2's here cancel, and you are left with square root of 2. Okay, next one, number 4. Now we've got this 2 here, and we haven't had that yet in our example. So this goes back to our rule here. So the a in this example will be a 2, and so you're going to put the 2 here and then divide by 2. So what is the integral of secant squared? That is going to be tangent. So I'll say tangent of 2x and then divide by 2. And then I'm evaluating it from pi over 4 to 3 pi over 4. All right, so I'm going to speed this up a little bit.
So I have the 1/2 here in front, and then tangent of 2 times 3 pi over 4 minus the 1/2 tangent of 2 times pi over 4. And then this is 1/2 tangent of 3 pi over 2 minus 1/2 tangent of pi over 2.
And then what? Tangent of 3 pi over 2, I always have to think unit circle here. 3 pi over 2 is down here. It's always the y divided by the x. Aha! We have got ourselves a problem. See, this coordinate point here is 0, -1, and the x value is on bottom. You can't do this. Tangent here would be undefined at 3 pi over 2. Tangent of pi over 2 would be undefined. And in fact, we can't even do this problem because this is the secant is the reciprocal of 1 over cosine, right? Okay, so if we're going to have 1 over cosine of 2x, of course, on this interval, there's going to be times where cosine is a 0, and so it's not even continuous. So this one is going to give us a broken problem. We can't do this one. It's unsolvable. So I didn't do that on purpose, actually, when I made these notes. But so you can still see the idea of how we set it up. That's fine. And then we come across our problem of that we had a restriction on the domain, so we can't even plug in these numbers. So let's just say that it's undefined. You can't do this one. Okay, I'm not going to do that to you in the practice. So keep in mind here that the most important part was setting this up and then understanding your trig values of how to plug it in. All right, number 5, let's do this one. On this last one, it should be fixed on your notes, but I wanted it to say -pi over, not over 4, but let's say it's over 16. So on your notes, again, that should be correct. That way this will work out correctly for us. So what I'm going to have you do is try this problem all by your lonesome. Pause this video now, and I'll have the answer appear here in a second. You can check how you did. Okay, there you go. This one was a little bit complicated because you had the secant stuff going on. You can try to follow my steps here, but I basically left the 1/4 in front this time instead of having it distribute to both of them, like I did on this with this 1/2 on the previous problem. And then I took secant and made it the reciprocal 1 over cosine, because for me, I have a hard time like remembering what in the world is secant of 0, but I know my sine, cosine, tangent with reference triangles or with unit circle stuff. So I just made it 1 over cosine and then took the reciprocals and distributed the 1/4. So there you go. Inverse trig derivatives, or you might see on the AP exam, arcsine or arctangent, that type of thing. That's the same thing as just the inverse. Sine inverse or arcsine is identical. What I want you to do is try to write out these 3. Over here, we just have their opposites. If it starts with C, it's going to be its negative version of an inverse trig. So to help you out, this is something that you want to get memorized. And so we did this earlier this year where we're going to focus in on these things. If it starts with an S, it's going to have a square root and a subtraction. So you got to remember that this is 1 over something. So 1 over, S's have square roots and subtraction. So again here, the S has a square root and a subtraction, but on the sign, Okay, that's the only hint I'm going to give you. See if you know. If you don't know, keep watching here for just a second. Pause if you can do it yourself. Okay, there we go. Here's our answers here. If it has a S in it, it has subtraction. If it was sine, it has a little I in there, then the 1 comes first. If it's got the C, it's like, ah, crap, there's an absolute value. You got to put that absolute value in there. And then the tangent, it has no S, so there's no subtraction, and there's no square root. So it's just addition, and it doesn't matter. You could put x squared plus 1 or 1 plus x squared. And then their complementary trig, inverse trig, values, it's exactly the same thing except that they are negative when it starts with a C. Okay, so let's use this stuff. This one's pretty straightforward. We've got a negative, so we know it has to start with a C. It's an inverse one. And what else do we have? Subtraction, and the 1 comes first. So normally it would have been the sine inverse, but it's going to be the complementary of that. So that means cosine of, and then what's the square root of that thing right there? It's just an x. Oh, I forgot the inverse. So cosine inverse plus c. There we go. That's it. Okay, let's identify this one. So that square root of that right there would be 3x. The derivative of 3x would be right there, 3. So this is going to work because you have to think, if you took its derivative, of whatever we're going to come up with, if you took the derivative, would you get back to this? You'll see what I mean here. So there's no subtraction and there's no square root, so we're going to do tangent inverse. And I know it's tangent, not cotangent, because we're not negative. And then what is the original angle here? It would be the square root of this, which is 3x, and then plus c. So if I took this derivative, you'd get 1 over 9x squared plus 1, and then you'd have to times by the inside and get 3. That's where the 3 comes from. So you can kind of double check yourself by taking the derivative. All right, let's try this one. Number 8. So you'll think here, what is the square root of that thing? That would be 2x is the square root. So we have a negative, so we know it starts with a c. And then normally, without the negative, this would be the secant one. It has a subtraction in it, a square root, and then an absolute value here in front. So this is cosecant inverse of 2x plus c. Look how easy this is. No problem. All right, square root, 1 in front. Square root with a 1 in front, that's sine. So sine inverse. Now what in the world is the angle going on here? Think about what the square root of this would be. The square root of that term would be 5x to the 4th. And if you took its derivative, the derivative of the inside, you get the 20x cubed on top. So that is perfect. So this is sine inverse of 5x to the 4th plus c. Okay, that is the end of this lesson. Remember, on the practice, you're going to have both integrals and derivatives, so you got to keep track of which way you're going. It's a common mistake to get those mixed up, so I'm going to throw them both at you right now. All right, rock that mastery check, and I will see you back in the next lesson.